Hello guys, my name is Balkrishna Shrivastav and welcome to Code with BK. So in this video we write a function to insert a node at the given index in the linked list in C programming. So before we begin, it is a request to please subscribe to my channel, and if any of my previous videos has helped you out or if this video helps you out, so please do subscribe to my channel. So we have to write a function to insert a node at the given index in the linked list, alright, for C programming, and this is the function that we need to complete. It takes the head of the linked list, the value to be inserted, and the index in which this is to be inserted, returns the updated head. Okay. And we in this series about linked list in C programming saw linked list from absolute zero. That what is the idea of linked list? Linked list is basically made up of nodes. Nodes are linked together using a link which is facilitated by this next pointer within this struct node, right? So you can go from one node to the another, right? So this linking of nodes together forms a linked list. And then we saw functions to find the length, print the linked list in reverse, insert at front, insert at end, and get the value at a given index. Okay, all right, now we have to complete this function. So suppose if I have a linked list, say maybe 4, 13, 11, 3, 100 and null. Okay, and this is my head. Okay, so at a lot of times in my explanation I use lowercase null, means the same thing as uppercase null. Okay, and no difference. Okay, suppose I have to insert 65 at index equal to 2. All right, so how do we provide indices in linked lists? Right, traditionally, conventionally, indices start from 0 from the left hand side, then 1, 2, 3, 4, very similar to that we have in arrays. Okay, so for values 4, 13, 11, 300 in this order, in this singly linked list, indices are 0, 1, 2, 3, 4. Now if I have to insert x equal to 65 index 2, this is index 2, I want to insert 65 at this particular index. So the order of values that I expect in my resulting linked list is 4, 13, then 65 at index 2, and then the remaining values 11, 3, 100. So the updated indices are 0, 1, 2, 3, 4, 5. Okay, I want a linked list that has values in this order. So when I want to insert 65 at index 2, I get 4, then I get 13, then I get 65, then I get 11, 3, 100 and null. Okay, and this is 0, 1, 2, 3, 4, 5. Okay, all right. So for this linked list, the length is 5. Okay, 5 nodes. So valid indices are going to be 0, 1, 2, 3, 4. For invalid index, okay, I simply return. I don't do anything. Invalid index would be less than 0 and greater than len. Okay, now length is not a valid index. Okay, length equal to 5 is not a valid index. In this case also, length equal to 6 is not a valid index. But when you are inserting at an index, usually in the requirement they say inserting at length index is equal to inserting at the end. That is, if in this linked list I say I want to insert, say, x equal to 17 at index equal to 6, which is essentially saying insert 17 at the end of the linked list, and so I expect my linked list to become something like this. Insert 17 at the end, okay, and null, so that the resulting indices, okay, 17 is at index 6, which I wanted. Okay, and in certain references you will also find that length is not a valid index. So they say if the index to insert is greater than equal to length, in that case it becomes invalid. So considering index equal to length, valid or invalid depends upon the requirement. Okay, for us, inserting at index equal to length is going to be valid, which is essentially saying inserting at the end of the linked list. Okay, so less than 0 is not allowed, greater than length is not allowed, and we also handle cases for head equal to null. All right, so inserting at an index can be divided into two cases, where index is 0 and second is index is greater than 0. Okay, we handle the case for index equal to 0 separately because it is actually changing the head, and whenever we change the head, we do that very carefully in linked list because we don't want our head to move around anywhere. We want it to be at the first node of the linked list, okay, the right way. Okay, so for index equal to 0, we can simply say insert at front. the code that we have already discussed to insert at front. Okay, all right. So if I start writing code, I handle invalid indices first. Okay, so if x is less than 0 or index basically is less than 0 or index is greater than length of this linked list, we return head. We don't do anything else. Okay, right. And in this case we are using the length function that I've already defined to find the length of this linked list. We will also see how to handle, code this entire function handling the invalid indices cases without using any helper functions as well by the end of the video. Okay, then we say if index equal to 0, okay, I say return insert at front passing head and the value to be inserted, which is x, and I return the updated head, else if the index is greater than 0. Okay, right. Again, using this helper function, by the end of the video we see if we don't have this helper function, how do we code this. Okay, we can simply pick up the code, this code from insert at front. Okay, all right. So moving on to this case where index is greater than 0, how do we insert? Let's just take this case, x equal to 65, index equal to 2, drawing the same linked list again. So within this linked list with indices 0, 1, 2, 3, 4, I have to insert x equal to 65. Okay, how do we do that? So we take I, which will show my current index, and we take current starting at head. Okay, so basically current points to the ith node in the linked list. Okay, so when we are starting our iteration, I is equal to 0, which is at the first node, and so current is also at head, which is the first node. Okay, and through the iterations, current will also point or will always point to the ith node. Okay, so we keep traversing from left to right, and the moment where we have I equal to index, okay, that is the case, that is the place where we want to insert this node. Okay, so when we traverse using previous and current, okay, where previous is equal to current equal to current dot next, I comes here, current comes here, previous comes here, previous starts with null. Then we do the same thing, I comes here, current comes here, previous comes here. Okay, previous is always one node behind current. Okay, when I equal to index, at this point we have previous pointing to this node, current pointing to this node. We say we create a new node with the given value, say 65. Okay, so when at this point, okay, if I equal to index, create new node. Okay, set next of previous to new node. Okay, so previous is at 13, right behind current, which is at 11. So this link is lost. Previous dot next is 65, which is the new node, and set next of new node to current. Next of new node is set to current, which is at 11. Okay, so the list that you get now is 4, 13, 65, 11, 300, which is what we wanted. Okay, so the idea is to start from previous and current pointers, iterate as long as this condition is not true. The moment this condition is true, we do these three points and then return head, because after we insert, there is nothing else left for us in the function to do, and we return head. Okay, that's how we handle the case for index equal to 0 and index greater than 0 separately, because in index greater than 0, head is not gonna change, head is gonna stay at the first node, so we can safely do return head after we insert. For index equal to 0, we have to make sure head always points to the first node, so after we insert the node, we update the head the way we do it in insert front. Okay, all right. So using the idea of current starting at head, node previous starting at null, and my ith index starting from 0, I'll say while current not equal to null. Okay, so you can also do something like this, which is equivalent to saying that current is not equal to null. So if this current pointer is null, the condition evaluates to false, else if this current pointer is not null, the condition evaluates to true. Okay, all right. If I equal to index, okay, we insert, okay, return head, okay, else we move forward. And since we know I equal to index will never be true for I equal to 0, because we are handling this case index equal to 0 separately. So we can start I at 1, previous at head, and current at head dot next. That is starting from the second node. Okay, starting from index 1, because index 0 is already handled. Okay, all right. To insert, we create a new node. So we can take this to create a new node. Okay, we say node, new node. Okay, next of previous is this new node. Okay, and new nodes next is this current. Okay, and then we return head. We simply say return head. Okay, because head will not change in this case, because we are not changing the first node. Okay, else we move forward. We say previous is current, current is current dot next, and I plus plus. Okay, I'll just dry run this in a moment and I'll show you how this works. Okay, so we are not handling the case for index equal to len anywhere. We can say else if index equal to len of head, we say return insert at end. Okay, right? But we are using helper functions in this case. If we don't have helper functions, we'll have to insert at index equal to length here if there is no helper function to insert at end. Okay, and finally we return head. Okay, and why do I say this? Because when this loop completes, it means I have iterated the entire linked list. Whenever I iterated the entire linked list, my I value will be equal to the length of the linked list. So if at this point I have I equal to index, okay, because I've already checked for greater than length, less than 0, equal to 0. All right, so if I is equal to index at this point, it means the index to be inserted is the length of the linked list. That we use when we don't have this helper function. I'll show you at the end, by the end of this video. Okay, so this is your code to insert at a given index. Let me just write some tests. Okay, 3 minus o. Okay, okay, so I will have to basically declare insert at end, okay, and then insert at front as well. Okay, because in C programming, if so, this function basically is using the two functions that are defined below them. Okay, that won't work if the declaration is not visible, which is right now in this case. Okay, oh, semicolon as well. Okay, so now I compile, it should be okay. All right, compiling and /ll insert 3. Let's see what I have. Okay, nodes in reverse order. Okay, I can delete this all. I don't need this. Okay, I only need print linked list. I don't need this, don't need any of this. Okay, looks much better now. Head equal to insert at end, 413 11 300, 4 13 11 300, and when I print the list, okay, I should get my linked list that we have discussed. So GCC 413 11 300. Okay, len barabar len equal to 5. Okay, now I'm saying insert at index 3, insert %d at %d. Okay, so insert x at index. Okay, all right, so let's see if we have a good output here. 65 at index 3, 0 1 2 3, it says 0. X at index, oh, I'm not insert at end, insert at front. Oh, I'm not setting the value of the node. Okay, so apologies, setting the value of the node. Okay, should be better now. Okay, insert 65 index is 0 1 2 3, so at instead of 3 it is here. Okay, now if I take index 0, Okay, so 65 will come up at front, so insert 65 at 0. If I say index say 5, okay, 0 1 2 3 4 5, it will come at the last. Okay, 65 comes at the last. If I say 3, this is still going to be okay. So 0 1 2 3 or 3 I've already checked, right? 0, let me just make it 4. So index 4 it is 65. Index 4 it is correct. 0 1 2 3 4. Okay, so let me just quickly dry run this. So I'll start with the same linked list: 4 13 11 3 100 null head. Okay, I have insert at index right. So same case, x equal to 65. I'll take index equal to 3 in this case. Indices are 0 1 2 3 4. Okay, I come to this part. Okay, current is here. Okay, previous is here. We have I equal to 1, I is here. Okay, current is not equal to null is true. Current is pointing to this node. We say if I equal to index, I equal to index is 3, I equal to 1, I equal to index is false. So we skip this entire if. Previous is current, current is current dot next. Previous is current, current is current dot next. I plus plus I becomes 2. Okay, so I comes here. Okay, we go back to check for while loop condition. Current not equal to null, current is pointing to this, not equal to null is true. If I equal to index, I is 2, index is 3, condition is false. You skip this entire if part. You come here, previous is current, current is current dot next. Okay, previous pointing to the node with value 11, current is pointing to the node with value 3, and then I plus plus I becomes 3. I comes here. Okay, checking the while loop condition again. While current not equal to null is true. If I equal to index, I is 3, index is 3, condition is true. This is where you insert. Okay, you create a new node. You say you create a new node with some garbage value. Okay, then you set the x, which I forgot. X is 65 in this case, so 65. You said previous dot next is new node. Previous is pointing to node with value 11. The next of this was pointing to 3. Now it is pointing to this new node. Then you say new node dot next is current, new node dot next is current. So new node dot next is the node with the value 3. Okay, and then you return head. So what you are returning is the list head, okay, which has 4 13 11 then 65 then 3 then 100 and then null, and your pointers are current is at 3, previous is at 11, and your new node is at 65. Okay, when you return head, we lose all local variables. Okay, and the list is 4 13 11 65 300. Indices are 0 1 2 3 4 5. 65 was inserted at index 3. Okay, all right. Last thing is, if you don't have helper functions, so what I'll do is without helper functions. Okay, so I'll say with helper functions. Okay, I'm gonna comment this entire thing till here. Okay, so without helper functions, I can do half of this condition. That is I can only check for negative indices. Okay, cannot use len, so this is okay. Okay, index possibility greater than len is not being checked yet. Okay, I can do this thing. If index equal to 0, I insert at front. So insert at front code, I can pick it up from here. I can say this entire thing. Okay, that if head is null, okay, if the list is empty, we create a new node. Else we create a new node, set x, set the next of this as to old head, and head is the new node. Okay, else. So now this entire else part is index greater than 0, which also includes index equal to len. Okay, in this part we can say return head. Okay, when index is 0, we update head and we return head. Index less than 0, we don't do anything, so return head as it is. In this part we copy the code, okay, for index greater than 0, okay, and since we do not have a separate helper method to insert at end, which can be done using this condition, because we cannot use len and insert at end, so we can add a condition here after the while loop, that if index equal to I, okay, that is I is length of the linked list after the while loop terminates, okay, that is if I'm able to traverse the entire linked list, okay, starting from I equal to 1, and this condition was never true, okay, it means current went to null, it means I was able to traverse the entire linked list. Current went to null, so I will be equal to the length of the linked list. I is equal to the length of the linked list after the while loop terminates, and if I equal to index, it means I have to insert at index equal to length, which is inserting at the last. So I can say create a new node, set the value x, okay, and set previous dot next is new node, because previous will be at the last node, because previous is right behind current, right, okay, and I also need to set new node dot next is null, otherwise I will may have an issue, right, and then finally I return head, okay. So not using any helper function in this case. If index is less than 0, I return head. If index is equal to 0, I use the code to insert the new node at the front of the linked list, okay. Else this part is greater for index greater than 0, so I start with I equal to 1. If this condition is true, it means index was equal to any index starting from 1 to less than len, okay. If this condition was never true and the control came here, and if index equal to I, it means I have to insert at the length, which is the last node, so I say previous dot next is new node, okay, and finally return the updated head. So the cases which were handled here, index greater than len is handled here. That if index is greater than len, nothing will happen, okay, you simply just return head as it is, all right, because this condition will never be true, this condition will not be true, so you return head, okay, all right. So you don't have to calculate length separately anywhere in this code, all right. So let's just run with the same set of tests. We start with index equal to 4, so compile and run, okay. So inserted at index equal to 2, 0, 1, 2, 65 is inserted at 2, and 11, 300 is shifted, okay. Then we can say insert at index 0, insert at index 0, 65 comes at the front, then 4, 13, 11, 300, len becomes 6, then index at length, which is 5, okay, last node, okay. So inserting at last, so 65 comes last after 100. If I have a negative index, nothing will happen. So for negative index, I should not be getting any changes in my linked list, stays the same, okay. Then for index greater than len, which is say maybe 6, okay, again the list should remain the same, len 5, all right, okay. So this was your function to insert a node at the given index, okay. And since we already have helper functions, so you can use this code, okay, and I'll say without helper functions, okay, all right. So I'll come clear, compile and run once again, okay, all good, okay. So this was your function to insert at a given index in a list in C programming, and I hope this was helpful. You like this video. So if there is any doubt, there is a part you do not understand, please let me know in the comments. I always try to answer all your comments, and you can also let me know in the comments if there is a question you want to solve or if there's a concept you want to discuss. So please like this video, subscribe to my channel, and thank you for watching.